Okay, I'm gonna test this now. I have the rotor magnets, the two rotors, 8 magnets in each rotor. And this magnet is in between these two magnets. So I keep talking about that. It's a triangular pattern. Now this magnet is in between these two magnets. Okay, so that's the way it is. So it's making AC now because this is facing south inward. This is facing south inward, so it knocks the coil one direction and then the other direction. I have both the motor coils and the generator coils again in series, and I'll just tell you what I'm going to do, because when I start it up it's kind of noisy. It's very annoying, so I'm going to tell you what I'm going to do, then you'll see me do it. So I have a 4 UF run cap. It's a rotiverter setup. I'm going to run from the grid over here. It's going to be drawing 100 milliamps and 120 volts. So it's going to be drawing about 12 watts into this motor, which does not get hot at all. It just runs cool. And it's going to be going 1800 RPM. And what you're going to see is it's going to be making 70 volts AC on the meter. And when I switch over from voltage to amps and just crowbar what's coming out of the generators with an ammeter for like maximum amps, it's going to show at first 160 milliamps here, and then I have a 3 UF cap. It's a 2 and a 1 in parallel. I tried different caps for this, and this is going to be in series on one of the AC lines coming out of the generator coils. So I have a series cap, and at first when I crowbar it without the cap, it's going to have 290 milliamps, and it's still going to have 100 volts. I mean 100 milliamps here when I crowbar it at 160 milliamps. No, what am I saying? Yeah, it's going to show 160 milliamps when I crowbar it, and it's not going to make any difference to the draw. However, when I put these coils in series, this 3 UF cap in series on the output going to the ammeter, which is shorting it out, it goes up to 320 milliamps. And the draw now will go up to 0.12, 120 milliamps instead of 100 milliamps. So I'm playing around with the output, and I tried different size caps, and this 3 UF is what works really well to boost the current coming out. The voltage will stay the same coming out with or without these series caps, but the current goes up quite a bit coming out. So I'm going to put this on a tripod and start it up. Okay, so this is the amperage going in from the grid. It's going to be reading pretty high, and then I'll unhook the start cap here. It's 20 UF, and it'll be running on the 4 UF start cap. This is the voltage coming out Right now it's voltage, and I'll be switching it around. Pulling this out and putting it over here into amperage, AC amperage. Right now it's in voltage. And this is the 3 UF run cap. Not a run cap, let's call it a resonant cap, series resonant cap on the output, 3 UF. Okay, so here we go. Should start right up. Give it a heave. I want to show you the air gap right now. There's the motor coil air gap's a little bit wider. I could make it a little more narrow. But remember, I have the motor coils hooked up with the generator coils. And here's the generator coil air gap, probably about just right. It's running on the start cap now. You can hear the tone. It's drawing 1 amp, so it's drawing 120 watts at startup. There, I took off the start cap. Now it's running with the 4 UF cap. And like I predicted, it's 100 milliamps draw, which is pretty good. So that's at 12 watts input. Here's the voltage coming out of those generator coils in AC, 70 volts. This is with both the motor coil and the generator coils in series, so it's like one coil in there. So 70 volts output. Now I'm gonna do this, or I put this over in AC amperage. It seems a little quieter than the other videos. When I made it that triangular pattern between the two rotors, it really spun smooth. Okay, I'm going to put this in 20 amps AC. Now I'm going to push it. There we go. You notice all of a sudden I'm drawing, I was saying 160 to 170 around there. And you notice the amps did not go up at all with all those generator coils shorted out. There's 8 of them. And now I'll make the amps input go up to 0.12 as we'll like double the current coming out by adding this resonant series cap, I guess you'd call it. Look at that. Isn't that nice? So now we have 320 milliamps out. However, the penalty of 20 milliamps more current input. And now I'm going to put this over, so we see 320 milliamps in a shorted condition. Circulating, you could say, and I'm going to put it over now into voltage. It's 600 volts AC. The voltage, it's just the same voltage you get with or without these caps. In capping series on one of the lines out from the generator coil. And when you checking voltage, there's no resistive load on it or anything, so you have what you have, 100 milliamps. Now I'm going to go back over to current. I'm going to short it out with this ammeter now in AC 20 amps. 320, and it does go up. However, if you remove those caps, it doesn't go up, but you have half the current. So, a couple choices what you want. Now, let's see, what I'd like to do maybe next is put a variac on this. I'm running on 120 volts. I bet you I could cut it down to like 85, 75. Maybe I'd have only 60 milliamps, maybe, I don't know. Because this is an AC motor latched onto the sine wave, so it's going to go the same speed regardless. If it's latched to the sine wave, it's going to be going 1800 RPM. So I have the luxury or whatever of lowering the voltage down to make the input draw less. So that would be one thing to do. Anxious to try it out. It's pretty good. It was yesterday was 53 volts, I believe. Went up to 66 when I had all of the coils in series. So I got about 4 volts more. I believe yesterday was 140, so I'm getting 160, but when I add this cap, I'm getting 320, which is pretty good. So, fairly happy with this. I wish I had wound coils, especially to be generator coils, not the split motor generator coils, but whatever. What I have. I was noticing if I look at just the generator coils, I'm getting 180 here, but not quite as much voltage. So let's do that. I'm just going to look at the generator coils right now. One minute. Okay, so this is only looking at the generator coils. The motor coils on this side are free. They aren't doing anything. And now I get 180 milliamps. And the voltage now on just the generator coils is 60 volts. So it's 60 volts compared to 70 volts, and probably about the same power, really. And again, if I crowbar it over here at the generator coils with the ammeter, the draw doesn't go up. For the fun of it, let's try the motor coils. See what they do. Just only the motor coils, the low impedance coils. Hold on a sec. Okay, you can hear it kind of lugging. Now just the motor coils, they make 1.12 amps. But they only make, and it raises the draw quite a bit, up to 190 milliamps. And the voltage, I took off the ammeter so there's no resistance on it. Voltage is only 14.6. So there's that. I'll do one final test with all of them together. Forget it. Can't get this camera to pause. Well, anyways, that's good enough. I'm going to call it a test. Okay, thanks for watching.